Alright, so this is the final problem set in this section, and this is about the monopolistically competitive firm. And this monopolistically competitive firm has a total cost function from which we can derive marginal cost and average total cost, and it is a demand function. But the demand function is for like a product category, something like cars or jeans or breakfast cereal, which is highly differentiated. And as you know, what happens in a monopolistically competitive firm or market is that the demand for, let's say, jeans or cars or breakfast cereal is being sliced up by market entry. So now let's illustrate how that works. So what this exercise will ultimately show is that in a monopolistically competitive market, each firm in its own market segment, which is highly differentiated, in each market segment they act like a monopoly, but at the same time they make zero economic profit, just like as in perfect competition. So it's a very interesting market form, and I hope this exercise will help to review again what's happening. So what I will do is I will first create the necessary graphs. So I start with the x-axis, so I replicate, or I put the graphs into a diagram like this one here. So I create an x-axis that starts at 0 and ends at 0. But what I will do now is I will make it a little bit more granular so that we can see the curvature of the average total cost function nicer. So I create a series with a step value of 0.1, but the series ends at 13. Okay, so now I create the demand function for like jeans or breakfast cereal or cars, and that is equal to 13 minus Q. Now I copy this down. Now we need the marginal cost function and the average total cost function. So the marginal cost function is the first derivative of the total cost function. So the marginal cost is the first derivative, so the 5 is gone. So now we have here 4, and here we get 2 times 1/4 Q, which is 1/2 Q, that's a plus. Okay, and average total cost is total cost divided by Q, so here we get 5 over Q plus 4 plus 1/4 times Q. Okay, let's add this. So marginal cost, maybe for firm I, average total cost for firm I. So marginal cost is 4 plus 0.5 times Q. Average total cost is equal to 5 divided by Q plus 4 plus 1/4 times Q. Of course we get a divide by 0 error message because we can't divide by 0. But now we can nevertheless copy down this formula, and maybe let's put everything also centered, and we don't really need that many decimals, so let's limit it to 1. Well, now it looks a little bit nicer. Okay, and whenever it says divide by 0, we typically replaced it by the number is not available. Okay, so now let's see what our graph looks like. Go to Insert, Recommended Chart, Okay, let's take the first one. It doesn't look too good yet, but we can fix that. So we can fix that by... Okay, so one problem that we see here is we don't need a legend for one. And we have these high values of average total cost for those super small quantities. So let's eliminate those a little bit. So actually we can do that in several ways. We can tell at the format axis, now I'll just go out of the way here, we can say that the maximum is supposed to be 13 and the step value is 1. Okay, and I don't need decimals, only takes away a lot of space. So we have here axis option, tick marks 1, that's correct. Display unit, number here, we don't need any decimals. And in the x-axis we also format that to make it look nice. So first of all, you want to see everything on tick marks, and you want an interval of 10, and then the labels also at an interval of 10. Okay, so now it already looks a little bit nicer. And maybe we want to add the grid line. Okay. And again, if you don't like that the average total cost function has so many high values, we can now just remove the, can make it look like this. And we don't need the title here, so now we know what's going on. On the x-axis we have the quantity, and here we have the price. Okay, so with this we should be able to work. Yeah, that's good enough. And okay, so now what do we know? So we have a monopolistically competitive market. Here we have the demand function for, let's say, cars or jeans or breakfast cereal. But imagine that initially there's only one. So the first question is, there's only one seller who's like the innovator of that new industry. And because the person is, or the company, the firm is the only one, they will act like a monopolist. So now we have to add the marginal revenue function. And the marginal revenue function for a monopolist, as you know, is twice as steep. So that means if the intersection is 13, that means twice as steep, it intersects at 6.5. So that's roughly here in the middle. So that is the marginal revenue function, and let's also maybe dash that. Okay, so now the firm acts like a monopoly because there is only one. And now, initially, that firm will choose the quantity where the marginal revenue intersects with the marginal cost, which is here. Okay, so we don't really know what that value is, but then the monopolist, or the first one in that monopolistically competitive market, will choose this price. Okay, so now what are these? So technically what we need to do is we need to equate the marginal revenue function which we know is twice as steep as the demand function. So the marginal revenue is P equals 13 minus 2Q, and the marginal cost function is 4 plus 1/2 Q, and that needs to be equal. So we need to solve 13 minus 2Q is the same as 4 plus 1/2 Q. Then we can solve for Q. Let's put them on one side, and we have 2.5 Q. So we put that on the other side. And we have to subtract the 4, so that is equal to 9. So now we divide 9 by 2.5. So Q star is 9 over 5 over 2, which is the same as 9 times 2 over 5, so that's 18 over 5, and 18 over 5 is, I guess, 3.6. Definitely a fraction. So okay, then we are done with this calculation. Let's erase it again. So 3.6. The next question is, what is the price? So that is relatively straightforward. So we have to subtract from the demand function, which is 13 minus Q, the 3.6, and then we get, of course, 9.4. So this value here is 9.4, and this one is 3.6. So assume that initially there is only one seller who is like the innovator of a new industry and who acts like a monopolist. How much profit does the firm make? Okay, so now we have to look again at total profit. And profit is total revenue minus total cost. And that is equal to 9.4 times 3 times 6, price times quantity, minus total cost, and the total cost function is 5 plus 4Q plus 1/4 Q square. So let's write that here again. So total cost was 5 plus 4Q plus 1/4 Q squared. Was that correct? 5 plus 4Q plus 1/4 Q squared, correct. So minus 5 plus 4 times 3.6 plus 1/4 times 3.6 squared. Okay, what is this? So let's quickly calculate that here. So we have total revenue is equal to 9.4 times 3.6 and total cost is equal to 5 plus 4 times 3.6 plus 1/4 times 3.6 squared. So profit is equal to this, total revenue minus total cost, 11.2. For the next questions, assume that the monopolistically competitive market is now in a long-run equilibrium. Okay, so for the long-run equilibrium, remember that the market is being split up. So what I do is I'll just take another demand function and overlap that with the existing one. I'll make it maybe. Okay. So if you remember, the only firm before any market entry, when there was only one, the firm supplied 3.6 and acted like a monopolist. So it chose the price of 9.4, but you can see the demand function is a lineup of people according to their willingness to pay. They could have been served at cost, which is lower than their willingness to pay, but they're not being served because the first innovator in that monopolistically competitive market acts like a monopolist. So now what happens is that this demand, that is the residual demand, but that is becoming a new demand for another market entrant. And then they act again like a monopolist. And then there's maybe again some residual demand, and then another firm enters the market. So the way to think about it, and in order to graphically solve the long-run equilibrium in a monopolistically competitive market, is to take the market demand function with the slope, and you slice it up until you get to a point of tangency with the average total cost function. That is the long-run equilibrium. And what will happen is that the market demand will slice up to a residual demand function, which looks like the light blue one. And now that residual demand function, the light blue one, is now the residual or the demand function that everyone in the market faces. Because every market entry drives down the prices, and maybe some consumers from one market segment move to the other. So we also have technically the law of one price. So this blue scenario here, the light blue scenario, is representative to everyone. Okay, so now we have the long run equilibrium, and now we have so we look at this residual demand and we create the marginal revenue, which is twice as deep. So it's the same thing. Even in the segment, we analyze it as if it were a monopolist. There's just an underlying market segment. Okay, so now, we see in the long run equilibrium, we have now a situation where marginal revenue intersects with marginal cost. Here, it looks like it is the quantity of 2. And each firm now acts like a monopolist, and they charge a price of 7. So this is the long run equilibrium price, and this is the long run equilibrium quantity. So we can see at the price of 7, the total market demand for, let's say, jeans or cars, that would be 6, but that market is now split up in 6 divided by 2, 3 monopolistically competitive firms that produce all the same thing, like cars or jeans, more or less, but they are differentiated. And we can see that each firm acts like a monopolist, because in each segment there are still some people whose willingness to pay is greater than what it would cost to serve them. So they act like a monopolist, which creates allocation inefficiency and a deadweight loss. So that is the monopoly element. And at the same time, because the price, which is equal to the average revenue, is equal to the average total cost, which means they are in a zero economic profit equilibrium. Okay, but let's see what the questions are. So for the next questions, assume that the monopolistically competitive market is now in the long run equilibrium. What is the long run equilibrium price? We just said, well, this is 7. What is the residual demand function? Well, it looks like it is 9 minus Q. So, what is the residual demand curve? And there is a typo, it should be actually P. Okay, so but it's 9 minus Q, so it's this one here. So the inverse, what is the residual? Technically it's the inverse demand function actually. So it's 9 minus Q. What is the residual marginal revenue curve? It's twice as steep, so that must be 9 minus 2Q. So that's B. What is the quantity that each monopolistically competitive firm supplies? Well, as we have seen, that's 2. And how many monopolistically competitive firms are there in the long run? Well, we know that at a price of 7, there is a total demand of 6. So there must be 3 firms in the market. Okay. And how much profit does the representative monopolistically competitive firm make in the long run? Well, we have already seen, because the price is equal to average total cost, there is zero economic profit. And lastly, which statement is true? In the monopolistically competitive long run equilibrium, each firm produces allocatively efficient. No, that's not true. That's not true, because as you can see, the price is above marginal cost. If the firms produced more, its cost would be less than people's willingness to pay, so that would be a win-win situation technically, but that's not happening. So there is no allocation efficiency. There is also no production efficiency, because the point of production efficiency would be at the minimum of average total cost. But the firm produces to the left of average total cost. So in other words, if the firm could produce more, average total cost would go down. But that's not happening, which causes some people to argue that in a world of monopolistic competition, we actually have too much competition. And sometimes when I walk through the supermarket and I pass, let's say, the aisle with all the cereal, I really think, yeah, there's maybe a little bit too much product variation. And that means that, you know, in the production of each individual cereal box, which is differentiated, like the one which is crunchy, the other one is chocolatey, and the other one is, I don't know, healthy or strawberry-y. So, you know, they could all be cheaper if there was less differentiation, and let's say there would be only strawberry and chocolate flavor, and not nut flavor and other flavors too, because then more of each brand could be produced, and then prices should come down. And that is why some people say in a monopolistically competitive market we actually have too much competition. But then again, I mean, there's also economic freedom, and if people can be fooled into thinking that the huge differentiation that we see in certain markets is necessary and this is what the market wants. I mean, who are we to tell people we have to reduce economic freedom just to bring average total cost down? I mean, if people want to buy it and it passes the selection test of the market, ultimately that's economic freedom, and that weighs higher than, you know, bringing down the production cost for jeans or cars or breakfast cereal. So it's neither efficient in terms of production nor efficient in terms of allocation efficiency. Okay, so now we solved everything graphically, and that's perfectly fine. But just for completeness, I still want to derive everything algebraically. So obviously for the long run equilibrium, the key is to find the point where the slope of the ATC is equal to the slope of the demand function. So the average total cost function was again, where did we write it down? Here we have the average total cost. It's actually, yeah, paste that here. Okay, so this is the average total cost. So now what we need to make sure is that the average, that the slope of the average total cost function, we need to find the point where it is -1. Because -1 is the slope of the demand function. So we have to take the first derivative and set it equal to 1. So we take the first derivative of the average total cost function, a function with respect to q. Okay, so that first term becomes -5 over q squared. To 4 there is no q, so that becomes 0, plus 1/4. There was no squared. I just want to make sure quickly, not that I make a mistake. Yeah, so that was just 1/4 over q. Okay, so that was the correct one, and that's the correct derivative, and that must be now equal to -1. Typically we say it must be equal to 0, but that would be a maximum or a minimum where the slope is 0 of a curve. So here needs to be -1. So let's see if we can solve that. So let's first multiply everything by q squared, so we get the q squared out of the denominator. So then we get -5, and then times q squared, that cancels out, plus 1/4. There was a q that I forgot. Oh no, I didn't forget the q. Hold on. Plus 1/4 equals so there's and I multiplied it times q, sorry. So we have here the q squared equals -1. And so now we can put the -5 on the other side. So we add on both sides 5, and then we have here 1/4 q squared equals 4. And I somehow feel I made a mistake here. Let me go back again. I think the average total cost function was it 5 over q? Yeah, okay, that was correct. I made a mistake. So we get Sorry, I just want to make sure total cost. So, okay, everything looks correct. Okay, so let's do it again, and I'm sorry that I was just confused by some of the results. So we have -5 over q squared plus 1/4 equals -1. Okay, so let's multiply both sides by q squared. Then we get -5 plus 1/4 q squared equals -1 q squared, not q squared. Okay, so now maybe let's collect terms. I have here a 4th q squared and here an entire q squared. So let's maybe put the q squareds on one side, and then I get here 1.25 q squareds, and then I put the 5 on the other side, and then we divide by 1.25, and then we get q squared equals 4. So now we got it. Yeah, I don't know, mate. Yeah, anyhow, so this is correct. So then the square root of q squared is, that's the square root of 4, which is 2. So this is how we can confirm that 2 is the optimum quantity that the individual firm in the long run monopolistically competitive equilibrium will choose. Okay, so Q, and okay, so we did this, so now we know how to solve Q. So Q star we set is 2, and then we plug it into the average total cost function. And in order to know what the long run equilibrium price is, it has to be 7. And again, ATC was, I can't remember ATC, 5 plus 4Q. So 5 plus 4Q plus 1/4 Q squared. Actually, that was the total cost function, so we have to do 5Q plus 4 plus 1/4 over Q. Is that correct? Yeah. Okay, I shouldn't have erased that. But the good thing is, if we plug in now 2, we should actually get 7. So let's see, ATC when Q equals 2, 5 over 2, 2.5, plus 4, 6.5, plus 1/4 Q, a fourth of 2 is 0.5. So we indeed get 7. Okay, so now we know that the long run equilibrium price is 7. And what we also know is that the inverse residual demand function, okay, got it. So now we have to find the residual demand function, and we know this has to be equal to P equals 8 minus BQ. Well, we already know that B is negative, or B is 1, because the residual demand function has the same slope as the market demand function for the group category. Okay, so but now I know what is A. I need to find A, so that is the only thing I don't have, that's the intercept. What is A? But that's easy because I know at the price of 7, A minus B is 1, Q is 2, because at the quantity of 2 the price is 7, so minus 2, so therefore A needs to be 9, and therefore the residual demand function is 9 minus 1 times Q. So this is how you would do it if you calculated everything manually. Okay, so but at this point you have a pretty good idea how prices are formed in different markets, specifically perfect competition, monopoly, and monopolistic competition. And yeah, so I hope that was useful, and I think it is useful because especially perfect competition and monopoly, they are important in modern day economic policy and competition policy. But anyhow, let's just stop here.